Hello students, I am Ranjana Verma, teaching you chemistry. We have been studying the chapter alcohols, phenols and ethers. So far we have studied the preparation, nomenclature, etc. of alcohols. And now we will study the properties of alcohols. One of the most important properties of alcohols is dehydration of alcohol. Dehydration means losing water. So when alcohols are heated with conc H2SO4 or conc H3PO4, then it loses a molecule of water, resulting into an alkene. As for example, let me tell you, ethanol, CH3, CH2, OH. When it is heated with conc H2SO4 at 443 Kelvin, it loses a molecule of water, resulting into an alkene, that is ethene. All alcohols undergo dehydration, but the rate of reactivity of alcohols is a 1 degree alcohol is least reactive towards dehydration, followed by 2 degree, followed by 3 degree. 3 degree is the most reactive alcohol towards dehydration. Now let us see the mechanism, because once we know the mechanism, we are able to predict the product. So first of all, we will see the mechanism of dehydration, how dehydration takes place. So we are coming with ethanol only. This dehydration takes place not in one step only, but a number of steps are there in sequence. Step 1, H2SO4 gives H plus ion. H2SO4 ionizes to give H plus ion plus HSO4 minus. Okay, now H plus ion. Now step 2, what happens? H plus ion attacks on alcohol. Suppose we are taking ethanol only, it attacks on alcohol. Which part it attacks? It attacks on oxygen atom, because there are two lone pairs of electrons on oxygen. So oxygen is able to form a coordinate covalent bond. It is able to coordinate its electron pair to H plus ion, and it results into a protonated alcohol. So alcohol is protonated in the second step, that is CH3, CH2, OH2 with a positive charge on oxygen. Now step 3. Step 3 is the generation of a carbocation. Now let me tell you, the oxygen is highly electronegative, you know it very well, and at the same time it develops a positive charge. So what happens? It draws the electron between carbon and oxygen towards itself and gets released from the protonated alcohol in form of H2O. H2O is lost in this step, resulting into a carbocation. So step 3 is the generation of carbocation, formation of carbocation. In this way, CH3, CH2, OH2 with a positive charge. This bond goes over here and we get a carbocation. This is an ethyl carbocation, CH2. Carbocation is highly active, short-lived intermediate formed. Now in the next step, what happens? That beta elimination takes place. This dehydration is an example of beta elimination. The H plus ion at beta position comes out from the carbocation as H plus ion, as a proton, and results into the formation of an alkene. So let us see how beta elimination takes place. This is step 4. Step 4. CH2, positive charge. This hydrogen comes over, this bond comes over here, and hydrogen is lost as a proton, and it results into the formation of minus H plus ion. It results into the formation of an alkene, that is ethene. So this is how dehydration takes place, resulting into an ethene. Now sometimes some unexpected product is also formed. The reason is that the dehydration of alcohol, the mechanism includes in one of the steps formation of carbocation. A carbocation, the stability of carbocation governs the entire route. You know that a tertiary carbocation, a 3-degree carbocation is the most stable, followed by 2 degree and then 1 degree. So 3-degree carbocation is the most stable, and so if suppose it is possible that a less stable carbocation can transform into a more stable carbocation, then it happens through an internal rearrangement. There are two ways of converting a less stable carbocation, that is 1 or 2 degree carbocation, into a 3-degree carbocation, that is either 1,2 hydride shift or 1,2 methyl shift. Let me give you an example, that is 3,3-dimethyl butane 2-ol. Here during dehydration an unexpected product is formed. Let me tell you how. I am just cleaning the board. Dimethyl, sorry, 3,3-dimethyl butane 2-ol. This is 3,3-dimethyl butane 2-ol. It is supposed to give one kind of alkene if dehydration takes place and a carbocation is formed, a positive charge is developed on this carbon atom. A different kind of alkene should be given as per the expectation if you see the entire thing in one glance. But actually it results into the formation of this alkene. CH3, double bond, CH3. That is 2,3-dimethyl-butene. 2,3-dimethyl-butene. Next day I will tell you how to predict, how to understand the mechanism of this. Thank you very much.